Right about now, we're talking about Coulomb's law. Okay, Coulomb's law is concept in physics that explains how charges interact. Okay, now let's say we have a charged particle. Charged particle could be positively charged, okay, or negatively charged. So let's say this is a charged particle Q1, and it is separated from another charged particle. Okay, let's say this guy is negatively charged. We call this Q2. All right. Now, from Coulomb's law, we could get the interaction between these two charges. Okay. Now, this interaction could be an attractive interaction, okay, or a repulsive interaction. Remember from the law of electrostatics, remember that when two charges are like charges, they are going to repel. But when two charges are unlike charges, they are going to attract. So it means that we can state Coulomb's law as the force of attraction. Coulomb's law states that, okay, the force of attraction or repulsion between two charges is directly proportional to the product of the charges. Okay, so it means I can say by Coulomb's law, F, which is the force of attraction or repulsion, is directly proportional to the product of the charges Q1, Q2, and inversely proportional to the square of the distance apart. Okay, so remember that between these two charges, we could have a distance. Let's call that distance R. Okay, R is the distance between the two charges. Okay, now we said Coulomb law tells us that the force of attraction or repulsion between two charges Q1 and Q2, for instance, is directly proportional to the product of the charge and inversely proportional to the square of the distance between them. Okay, so the distance between them is R, so it becomes the square of R. Now remember that in mathematics, when we take away the proportionality symbol, we bring in the equal to sign. So we can say that F is going to be equal to, we're going to introduce a constant. The constant, let's call it K. So it becomes KQ1 Q2 divided by R squared. Now, remember that this K is the constant of proportionality. It's called Coulomb's constant. Okay. Now, Q is our charges. Unit for charge is coulombs. Okay. So we could say that K is Coulomb's constant. K is Coulomb's constant. And we could obtain the unit for K. Okay. What becomes the unit of K? The unit for K is Newton's. Okay. Newton's meters squared per Coulomb squared. That's the unit for K. Newton's meter squared per Coulomb squared. Okay. Now also, what is the value for K? The value for K actually depends on the medium of the charges. Now, if the value for K is equal to 9 times 10 raised to the power 9 Newtons meter squared per Coulomb squared, then it means that the charges are in free space or vacuum. This means charges are in free space, or you could say vacuum. Okay. Now, there's an expression for this result here. K, if K is 9 times 10 power 9, it means that K is equal to 1 over 4 pi epsilon naught. Okay. So when K is equal to 1 over 4 pi epsilon naught, it means that what we have is free space or vacuum. And this result is 9 times 10 raised to power 9. Okay? What does that tell me? It simply tells me that K could have another value, okay, which is for medium. Now, K for medium, if K is in a medium, K for medium should be 1 over 4 pi epsilon. Okay? Now, what does epsilon mean? What does this mean? What does this guy mean? This guy is called permittivity. Okay? It's called permittivity. Permittivity. Okay? Now, we could have three types of permittivities. We have the first one is called absolute permittivity. We have relative permittivity, and we have permittivity of free space. Okay, this guy, don't forget, is called absolute permittivity. So when you see, it's called absolute permittivity. Okay, now when you see epsilon r, it is called relative permittivity. Relative permittivity. Now when you see epsilon naught, it is called permittivity of free space. Permittivity of free space. Now, relative permittivity can also be called dielectric constant. Okay, can also be called dielectric constant. Now, what is the relationship between three of them? Okay, relationship would be that absolute permittivity, absolute permittivity is equal to the product of relative permittivity and permittivity of free space. So it means that when the system of charge is in a medium, okay, the value for k for medium, therefore, the value for k in medium becomes 1 over 4 pi, where we see permittivity, absolute permittivity, we just put there E naught and ER, okay? Product of E naught and ER. But remember, we have said something already before. We said that 1 over 4 pi A naught, we said that it is equal to 9 times 10 raised by 9. Remember, so we can replace 1 over 4 pi A naught there. If we do that, the result is going to be everything here becomes 9 times 10 raised by 9. So we have 9 times 10 raised to power 9. Okay, all okay multiplied by 1 over ER. So finally, K for medium is equal to 9 times 10 raised to power 9 divided by epsilon r. Okay, finally. So what I should take note from here is that uh, K for medium, this is the formula for your electrostatic force. This is the formula. Okay, now I'm going to show you how we can represent this formula in different forms depending on how the question comes. Okay, so now what we've said here, we have that K is equal to 1 over 4 pi epsilon naught. When it's epsilon naught, remember that it is permittivity of medium. Okay, so the system of charge, when it's epsilon naught rather, when it's epsilon naught, remember that the charges is in a vacuum. Okay, and K should be 9 times 10 raised per 9. Remember that E naught is permittivity of free space. And remember that E naught has a value. Don't forget, E naught has a value. The value for E naught is equal to 8.85 times 10 raised power minus 12. Okay, minus 12 Coulomb squared per Newton's meter squared. Okay, this is the unit for epsilon naught, and this is the value for epsilon naught. All right, be able to establish a concept that from Coulomb's law, the Coulombic force can be KQ1 Q2 over R squared. We've been able to establish this, okay? And from this formula, we're able to establish also that if the system of charge is in a vacuum, that is free space, meaning that vacuum and free space go together. If it's in a vacuum, it means we can say that F becomes, where we see K, we can put 9 times 10 raised to power 9, okay, Q1, Q2 over R squared. Okay. Now, when you use this formula, remember that it would have been that the system is in a vacuum or free space. Now, also, if the system is in a medium is an environment of the charge. A medium could be oil, it could be water, it's an environment of the charge where the charge is placed. If the charge is in air, it is called free space. If the charge is in a medium, is in water or anything else, it is called medium. Okay. Now the force when it's in a medium, okay, becomes where we see K, it becomes 9 times 10 raised to power 9 divided by epsilon r, okay, Q1 Q2 divided by R squared. Okay, now it means that once the question tells us that the system of charges is in a medium, we're gonna replace K with 9 times 10 raised per 9 over epsilon R. Remember, that epsilon r is permittivity. Okay, it's called relative permittivity. Okay, that's the permittivity of the medium. And remember that ER has no unit. AR is a constant that depends on the medium. Okay, so this formula, we use this formula for force if the system of charge is in a medium. Okay, another thing to take note of is sometimes they'll tell you that some questions will tell you that the charges are similar. Okay, charges are the same. If the charges are the same, what comes to my mind? What comes to my mind? The charges are the same. So I would say when the charges are similar, okay, if we have similar charges, what should I know? I should know that Q1 would be equal to Q2. Everything should be equal to Q. So that changes my formula. The formula becomes F is equal to K. Where I see Q, I would write Q squared divided by R squared. Okay. So I'm using this guy when the test question tells me that the charges are the same, charges are similar. Now, what is the most correct form of writing this formula? Remember that the most correct form of writing this formula should be like this. F is equal to K modulus of Q1 multiplied by modulus of Q2 all divided by R squared. What does this tell me? It tells me that when solving, your charges should be taken as positive. Even if you solve, even if the question tells you that the charge Q1 is negative 2 times 10 raised per minus 6 coulombs, for instance, okay? When solving, you don't need to include the sign. You can take a positive charge to solve, okay? It's very, very necessary, very important. Now, again, what is the relationship between F and R? You can see that F and R are inversely related. Okay, F and R squared. Okay, the relation between F and R squared is that F is inverse proportional to R squared. What does that tell me? It tells me that if I vary these two, it tells me that F1 R1 squared will be equal to F2 R2 squared. Okay, this is another formula that is very important. So the formulas I've written on the board now, they are very, very necessary. When do I use this formula to solve? I will use this formula when the question varies the Coulombic force and the distance between the charges. Okay, this formula becomes very, very useful. Okay, all right. Now Coulomb's law asks two principles that governs charges. One of them is principle of charge conservation, and the other one is called principle of charge quantization. Okay. Now, what is the principle of charge conservation? All right. What's the principle of charge conservation? In the book of chapter, so it tells us that in a closed or isolated system, in a closed or an isolated system, the total charge is zero. What it means is that charges cannot be created, charges cannot be destroyed, charges can only be transferred from one object to another object. It also implies that if, for instance, I have a system of charge, okay, on two objects, when an object loses electrons to the other object, to another object, okay, it becomes positively charged. The other one gains by the same amount of electron to become negatively charged. Okay. So if I find the sum total of the charge in a system, the result is zero. If I find the sum total of the charge in this a system, the result is zero. Okay. So that is principle of charge conservation. Okay. Then we have another one called the principle of charge quantization. Quantization states that charges exist as whole number multiple of elementary charge. Now remember that the elementary charge, okay, the elementary charge is E. That's called the charge of electron. Remember. Now, the principle of charge quantization states that charges exist as an integral multiple of the charge E. Or you can say charges exist as an integral multiple of elementary charge. That is why you have this formula Q equals NE. So when you see Q equals NE, Q stands for total charge, Ln is an integral. Again, E is the elementary charge. You could still state principle of charge quantization as charges. It states that charges exist as a whole number multiple of elementary charge. So what it means is that, let's say for instance I have a charge Q and the charge is equal to minus 3.2 times 10 raised to power minus 19 coulombs. This can be written as negative 2e. You can see that I have been able to write this charge as a whole number multiple of what? Elementary charge. So by a principle of charge quantization, I should be able to place every charge as a whole number multiple of elementary charge E. Another instance, let's say for instance we have Q, okay, we have Q as minus 4.8 times 10 raised to power minus 19. This guy can be written as 3, okay, can be written as 3, okay. Okay, this is 2e, not negative, no, this is 2e. So this guy can be written as 3e, okay, which means 3 times the charge of electrons, all right, the same thing. So this is this is what we say when we talk about principle of charge quantization. Okay, now remember that this your E here can be charge of electron or proton. Okay, so E is charge of electron, charge of electron or proton. Okay, Q is the total charge. Remember, Q is the total charge. Okay. All right. The question here tells us that we have, it says two small sphere in a vacuum. So remember they said vacuum. Okay. We know what vacuum means, free space. Are 2.5 meters apart. Okay, which means that R equals 2.5 meters. Okay. And it says center to center, they carry identical charges, which means that Q1 is equal to Q2. Let's call them to be equal to Q. Now, they said they carry identical charge. As you think, each of them carry identical charge. Now, they said how large is the charge on each, which means they're asking for this Q, if each sphere experience a force of 2 newtons, which means the electrostatic force on the sphere is 2 newtons. So how do we look for Q? We can remember the formula I gave for electrostatics, okay, for Coulomb's law, that tells us that F is equal to KQ squared over R. Okay. Now we can decide to make over R squared. We can decide to make Q subject of the equation. If we do that, Q is going to be equal to the square root of F times R squared divided by K. Okay, so with this formula, making Q subject from this formula here, we could find the value of K. Okay, so the value of K therefore becomes Q is equal to, the value of Q becomes square root of, where I see F, I'll put 2, so it becomes 2 times R is 2.5, 2.5 squared divided by K. Now, the next question is what value of K am I going to be using? Is it K for medium or is it K for free space? Now, because the question said the spheres are in a vacuum, so it means our value for K should be 9 times 10 raised to power 9. Okay, so at this point you can just punch your calculator. You can just punch your calculator here. 9 times 10 to the power of 9. You get you're gonna get, this is 3.7268 times 10 to the power of negative 5. This should be in coulombs. Okay, should be in coulombs. Now I've gotten the value of Q, okay, in a vacuum. Okay, now the next question B says if the spheres are placed in a medium of dielectric constant, okay, if the spheres are placed in a medium of dielectric constant 80, it says calculate the charge. Now, this is another question here, okay, that tells us that if the charge are now removed from a vacuum and placed in a medium. Now, remember I told you that if the charges are in a medium, what formula do we use for Coulombic force? Remember that if the charges are in a medium, it becomes F is equal to 9 times 10 raised to power 9 divided by ER. Remember we said ER is the electric constant times Q squared divided by R squared. Okay. So if the charges are placed in the medium, I'm going to be using this formula. Now the same way, make Q subject. If I make Q subject, my Q therefore is going to be square root of F times ER times R squared divided by 9 times 10 raised to the power of 9. So I've made Q subject here. Substitute the values we have square root of put our values. Our F is 2, ER is 80 from the question. Okay. Then the distance is 2.5. So put 2.5 there. Squared divided by 9 times 10 raised to the power 9. Okay. So in the same way, you can use your calculator and obtain the value. Okay. The value becomes 3.33 times 10 raised to the power negative 4 coulombs. Okay. So when the charge is in a vacuum, okay, when the charges are in a vacuum, this becomes the value of the charge. When the charges are in a medium, this becomes the value for the charge. All right, the question here says two small spheres placed 30 cm apart, which means the distance between them is 30, okay, have equal charges. We know what that means. It means Q1 equals Q2. It says how many excess electrons must be present on each sphere if they experience a repulsive force. So it means that the force, okay, of repulsion is 2.3 times 10 to the power of negative 22. Okay. Assume vacuum. If you assume vacuum, it means that our value for K is 9 times 10 to the power of 9 18 meters squared per coulomb squared. Now they're asking us for how many excess electrons, which is what is the number of electrons. That means that we're looking for n value. Okay. Now, first thing we have to do is to look for Q. Remember that from the principle of charge quantization, remember we said that Q equals NE. Okay. So if we get the value of Q from this formula here, let's get the value from Q first. How do we get Q? Remember that from Coulomb's law, F equals KQ squared divided by R squared. So we're going to obtain the value of Q from here. How? Q becomes square root of, make Q subject, F times R squared divided by K. We get Q from here, which means my Q therefore becomes square root of, the value for F is 2.3. We put the value for F here. Okay. Value for R is 30. But the 30 is 30 cm. If we move 30 cm to meters, we divide by 100. That will give us 0.3. So we have 0.3 squared divided by K is 9 times 10 raised to the power 9. Okay. Now we can use our calculator here. Use our calculator there and obtain K. We're having 4.7958 times 10 raised to power minus 17 coulombs. Okay, this is what we're having now. So once we have obtained the value of Q, we can now apply this formula, okay, to look for N. Remember that N is equal to Q divided by E. From here, we can make N subject. Now Q is 4.7958 times 10 raised to power minus 17. If we place the value of E, you know E is charge of electron. That will be 1.6 times 10 raised to power minus 19. Okay. So if we do this now, we're going to be having this answer. Okay. If you use a calculator, you're going to be having 299.74. Okay. 299.74. Now we can approximate to 300. So approximately n is equal to 300 electrons. Okay, n equals 300 electrons. All right, this question here says, what is the total charge in coulombs of the electrons in 3 moles of hydrogen atom? Okay, now what is the total charge in 3 moles of hydrogen atom? So what we need to do first of all is to look for the number of electron n of hydrogen atom. Okay, we look for the number of electron. Now, there's a formula for number of electron. How do I obtain number of electron? It is equal to number of moles multiplied by Avogadro's number. Okay, number of electrons is equal to this. So the number of electrons in the hydrogen atom is equal to the number of moles times Avogadro's number. Now, what is Avogadro's number? Remember, the Avogadro's number is 6.02 times 10 to the power of 23. Okay, yes. So this is Avogadro's number. Now, so to obtain the number of electrons, I would say the number of electrons becomes number of moles in the equation is 3. So it becomes 3 times Avogadro's number is 6.02 times 10 raised to power 23. Okay, okay. So that gives us 18.06. Okay, times 10 to the power of 23. Okay, that's what it gives to us now. Now, the next thing I'll do here is, how do I get the total charge? Remember that your total charge is equal to number of electrons times E. Remember, okay, number of electrons times E. So this is number of electrons times E. Now we have found number of electrons. Remember that the N this time means number of electrons, okay? So number of electrons is now 18.06 times 10 to the power of 23. Then multiply by charge of electron is 1.6 times 10 raised to power minus 19. Okay, so at this point we can obtain our answer here. So our answer here gives us the total charge here becomes 288,960. Again, so the total answer therefore Q becomes 2.89 times 10 to the power of 5 coulombs. Okay,